Hey everyone, in this video we're going to have a look on how to create a custom UI component in Unity Engine. So what we're going to do here is create a 2D polygon and render as a UI component, right? So if you look at this ellipse UI, and it is a UI component, and if you look at this script, it is derived from graphic, right? So one of my audience has asked me about this OnPopulateMesh, how to use them and how can we draw an ellipse as a UI, right? So if you modify the rect size, then you can see that it is automatically gets updated. This is what we're gonna implement in this video. So let's get started. So here I have very simple scene, and this entire project is available on my GitHub. So I have created a new repository which is called YouTube tutorials, and it will contain all the sources for all my YouTube tutorials that I have been working on. Though I'm not sure about how to structure this repository for each tutorial. So, but for now what I'm doing is in this asset folder, we would have different folders for different tutorials. So you can just check out all these folders and you can see all the code, right? So for this tutorial, it is already here, and I'm gonna rewrite this throughout this video and explain how it is working, right? And my suggestion would be is to not to just copy paste on your project, but instead try to read and understand it with the help of this video, and then implement by yourself in your project, so that you will get the understanding how it is working, and you might also implement more complex things, right? So at first we will try to draw a quad. After this we will draw an ellipse, right? Because ellipse is a little bit difficult to draw, we will try to understand first the fundamentals. And if you're also wondering about how the meshes are being rendered, how its vertex and triangle indices are being set up, you can check out my video. I will give you the link in the description. So this is my ellipse UI component. I'm just open this. Let's clear all these things, right? So let's make the font a little bit bigger so that you can see actually what is happening in low resolution also. So at first we need to add some using UnityEngine.UI using Unity Engine. Okay, now public class ellipse, and it must derive from graphic, and make sure this class name must match with the file name, and accessibility of this class is not required to be public, so you can also make it private or just leave it blank. Okay, now in this graphic base class we have a function what we call OnPopulateMesh. Okay, so let's see where it is. Okay, so we have the two overloads, right? These are all virtual functions and it is protected, so we need to override it. First is for mesh, and this is the VertexHelper. So what we're gonna do is to use this function. We are not gonna use this because it will little complex, like we need to create an array, set up the vertices. These are all things that we need to do. But this VertexHelper, what it does is automatically manage all the buffers, I mean triangle indices, vertex, all the stuff, right? So let's copy this and protect it, override void, and we have vertex helper, let it be helper. Okay, so at first we will try to draw a quad, so let's save it. Okay, now you can see that nothing is being drawn on the screen. Why? Because there is no polygons, right? We are not drawing any polygon. So what we need to do is to create UIVertex. This is a struct, and let's create a simple vertex. Okay, so after this we have a vertex. Now we can push all the vertices by setting its position. If you haven't watched my video on drawing a quad in Unity Engine, then you must check out that, because it is necessary to understand how the triangles and polygons are being drawn. So for a quad we have 4 vertices, right? So let's say we have top right equals to 100 by 100. So we are assuming that we are drawing in screen coordinates. So top left would be 100 by 100, and bottom left would be minus 100 minus 100, then bottom right would be 100 by minus 100. Okay, so these are the 4 vertices, and what we need to do is draw from top right to top left and then bottom left, right? So we need to move in anti-clockwise sense. You need to draw a triangle in anti-clockwise sense, right? Otherwise, if you are doing in clockwise sense, then you won't be able to see in from the front side, meaning it would be invisible in the game window, right? So let's do that. Vertex.position equals to new vertex, new vector 2, 100 by 100, then vertex.position new vector 2 minus 100, okay. Now this code does nothing. To make this work, what we need to do, push all these vertices inside this, right? So let's do this. Oh, sorry. Helper dot add vert, which is position, right? So it has index of 0. Sorry, it is vertex. Then we have helper dot add vertex, and make sure you are familiar with value types in C#, though it is not very required. Just to be aware of the basics of C#. I will also try to make a video about that. Okay, we have filled up the vertex buffer, but still the indices or index buffer is yet to be filled, right? So how we can do that? Helper dot add triangle. So what we need to do is to draw the triangles in anti-clockwise sense, meaning 0, 1, 2, and helper dot add triangle. Here you might get confused how we can do that. So this is, let's say, top left, right? Now this is top right, and this is bottom left, and this is bottom right. Okay, so for the first triangle, what we are doing is to drawing from here to here and then here. So this is what we call anti-clockwise sense. So similarly, what we can do is to draw the second triangle from here to here and then here, right? So as we know that top right has index of 0, top left has index of 1, bottom left has index of 2, bottom right has index of 3. So let's do that. Bottom left has index of 2, so let it be 2. Then bottom right has 3, then top right, which is 0, right? Sorry. Okay, now this code is now functional, and we will be able to see a code on the screen. So let's save it. Okay, now you can see that we have a code. Okay, now this will not fit into this rect transform. Why? Because we are drawing in completely outside. We are not considering any kind of things like what is the size of this rect. So we are not considering, it is all constant value, right? So what we can do is get the width and height, right? So how we can get the width? by getting the reference to the rect transform. Okay, now for the width, what we can do, rect transform dot rect dot width. Okay, and we have rect transform dot rect dot height. Width, just write width multiplied by 0.5 and height multiplied by 0.5. Then we have width multiplied by 0.5, then height multiplied by 0.5, then width multiplied by 0.5, then height 0.5, okay. So this way we can resize the code. Okay, now if I will resize, it is not happening as expected. So what is the problem? The problem is we need to call the base version of this function, right? In general, don't forget to call the base function if you're overriding a particular virtual function, right? As I did. So let's do that on OnPopulateMesh helper. Okay, let's save it. Now you can see that it is working. So let's change the color to white. Now it is working. So that was the basics of how the OnPopulateMesh works. Now let's draw an ellipse. So for ellipse, we need to understand how the ellipse are being drawn. We have an equation this, and this equation is satisfied by this parametric equation A, which is the major axis, semi-major axis, right? And B is semi-minor axis, and T ranges from 0 to 2 pi, which is 360 degrees. So this is what we're gonna do. So let's jump back into Visual Studio. Okay, now as we can see that it is a curved surface, I mean it is a curve, right? So anything which is a curve could be drawn by tessellating that into lines, right? Meaning we need to add some divisions to this. So as much there would be divisions, the smoother that will be looking, right? So what we can do is just write private int divisions, meaning how many divisions we want. So for now, let it be 20, and private float major radius. So we are just calling it major radius instead of semi-major axis. So major axis, let it be 200, and then private float minor 100. Okay, now if you are assuming that, for example, we have 4 vertices, meaning we need 4 divisions, so we will create a for loop which will run 4 times, meaning 1 2 3 4 for each of these vertices. So let's create a for loop. Okay, now apart from this, we need to increment the angle, meaning we will start from here, meaning the angle would be 0, and then we will go here, which is when the angle would be 90 degrees, right? Similarly, for this the angle would be 180 degree, and for this angle the angle would be 270 degree, right? So how we can do that is calculate delta angle, and delta angle could be calculated by mathsf.py multiplied by 2 divided by divisions, right? So float angle equals to delta angle multiplied by I. So here we're going to calculate the vertex position. So new vector 2. So we have major radius multiplied by math f dot sine angle, and minor radius multiplied by math f dot cos of the angle, right? So this is the position. There is another thing we should note is that the ellipse outline would have a thickness, so meaning we need to create a strip of chords. So let's add another vertex, major radius minus thickness. Okay, now let's add another parameter, which is thickness. For thickness, let it be 10. Okay, multiplied by math f dot sine angle and minor radius thickness. Okay, okay, now we need to push that into vertex buffer. So helper dot add vertex. Okay, now add triangle. So helper add triangle, right? So I'm not just calculating in my mind, I'm just looking this reference. This is also created by me. So how this actually working is we are drawing from 0 to 1, 3. If you imagine in your mind that we have a chord right here, so it will have 4 vertices, same as we have done previously, which is top right, top left, and bottom right, right? So since we are adding just 2 vertices at each iteration of the loop, meaning we would have 0 to 1. Let me check first. This is the bottom right corner and this is the top right corner. Okay, so let's swap this. So let's add a triangle, which would be 0 to 1 to 2, and helper dot add triangle 3 to 0. So 3 to 0. Since we are in the loop, we need to add some kind of offset. So let's add that. I multiplied by 2, and then offset plus this. Okay, now there is a problem is that this should be wrapped, meaning it might exceed the number of vertices or the maximum index possible. So what we can do is calculate the vertex count ahead of this loop. So vertex count should be equals to 2 multiplied by the divisions. Okay, now let's save this and run it. Okay, so it is not working. What we are mistaking is helper.clear, meaning since we are running in editor mode, then it might be possible that it is not clearing the previous vertex buffer. So yeah, you can see that it is working a little bit, some divisions. So there is some mistake on this triangle indices. So what is wrong is this is the major radius. We are adding everything correct, man. Okay, so here it is. So actually I made this by using my pen and paper, so always try to use that. So currently I can't record a video on that. Okay, now you can see that it is now working. One another problem is we want it to be resized in this, meaning we want it to be fit into this rect transform. How we can do that? This is the same as we did in quad case, right? So let's remove this major axis and minor axis. So what we're gonna do is var rect. This time we will just get the rect transform and float major radius is equals to rect dot width, and it should be 0.5. Minor radius is equals to rect dot height 0.5. Okay, now this should work now. Okay, now you can see that you can resize it. This might also become a circle. Let's make it circle. There's another problem is if I change the pivot, now you can see that it is shifting, right? Which we don't want. How we can get rid of this? By shifting the center of this polygon based on this pivot, right? So let's make it. We have vector 2, which is center. Vector 2 dot 1, sorry, 0.5 minus pivot. So what we're gonna do is let it be rect transform, and rect transform dot this. Okay, form dot pivot. Now we need to also modify it a little bit. So major radius multiplied by center dot x multiplied by 2, minor radius multiplied by center y multiplied by 2. Right, now we can add this center to the result. Oops, in this also. Okay, let's save it and see the result. Okay, now you can see that regardless of the pivot, it doesn't matter what is the pivot is, this will always be in the center within this rect, right? So this is how we can implement the polygons inside our UI, right? This would be in the canvas. I hope you have enjoyed this video. If yes, then make sure to subscribe and press the like button. Thanks for watching. I will meet you in the next video.